show these answers. If your answers are incorrect, check them, fix them, and then if you have questions on any of them, we can go through those. So number 1 was not in simplest form because it could be simplified more. 150 is not a prime number. So if you were to simplify it, now I just did it the shorter way. The highest perfect square that we can divide this by is 25. There was a negative on the outside, so this will become negative 5 times the square root of 6. Question on number 1. So this is starting on the side that says A, 3A, not 3B. Number 2, 196 is a perfect square, so that equals 14. And then looking at all your variables, so I just did it the method 2 goes into 3 once with 1 left over, 2 goes into 4 twice with nothing left over, 2 goes into 9 4 times with 1 left over, and then rearrange everything. So your final answer was 14xy squared z to the 4th times the square root of xz. Question on number 2. Number 3. I'm not sure what they did here, but something about this one. If you started to simplify 162, the highest perfect square that goes into it is 81. So the square root of that would be 9. Maybe they took the square root of 9 to get 3. I don't know. Because then they didn't multiply it by -4. And then simplifying your variables, 2 goes into 3 once with 1 left over. 2 goes into 2 once with nothing left over. So on the outside, we have -4 and 9. The a to the 5th that was already out there, the a that we simplified, and our 1b. If we were to simplify just the outside, it would be -36 a to the 6. Yes,
I'm just going to do about
about 2.
Yeah.
Hold that thought and multiply. And then on the inside, the square root of 2a. Questions on 3 first. Javier, what was your question about 2?
Okay, ready?
For you.
Yeah. I just need a unit or have a unit.
You mean right here?
Yeah.
You can put it right there.
Oh.
But it doesn't matter. So if it has a dot or if it doesn't have a dot, either way you're still multiplying. As long as it's next to it, it's still multiplying. Other questions on this side? On the back, for 3B, number 1, same process, but now these are cube roots. Take the negative out. The highest perfect cube that can go into 128 is 64. And then the cube root of 64 is 4. So our final answer would be -4 times the cube root of 2. Questions on that one? Number 2, we need to simplify again. The highest perfect cube that could go into 432 is 216. The cube root of 216 is 6. So 6 times the cube root of 2 would be our final answer. Questions on 2? And then for number 3, the highest perfect cube that went into 1944 was 216 again. And then 9 would be left. 9 is a perfect square, but not a perfect cube. And if we break down 9, its factors are 3 and 3, so we don't have a group of 3 to come out. So that is as simplified as possible. 6 times the cube root of 9 would be your final answer. You can also tell that this is not the final answer because I can break down 72 more to 8 and 9, and 8 is a perfect cube. So that is not as simplified as possible. Question on number 3. Before we start our new lesson for today, did we go over these 4 at the end of class? Okay, I just did not remember. So everyone should have these notes. Make sure those are in front of you. So far we've talked about how to simplify square roots and cube roots, and square roots with variables and cube roots with variables. Now we're going to be doing radical operations where we're adding and subtracting and multiplying radicals together. When we add or subtract radicals, 1, we have to make sure they're all simplified. If they're not all simplified, we need to do that first. Then we need to find radicals with the same index, so we can't add together a square root and a cube root. Those aren't the same. They have to both be square roots or both be cube roots. And then they also have to have the same radicand. So the number underneath needs to be the same. Think about this like terms. You can't add an x and a y together. You can't add the square root of 2 and the square root of 3 together. They're 2 different things. So once it's simplified and they have the same thing, then we can add or subtract the numbers on the outside, so the coefficients. But whatever's inside will stay the same. It's like when you add 3x and 5x, it's just 8x. You keep the x, and you're really just adding the numbers. Same thing here. So for this example, these are both square roots, but they do not have the same number on the inside of the radicand. So we would need to, 1, simplify the first one. So give me the highest perfect square we can divide 20 by. 5 would work, but that's not the perfect square. 4, yeah. So that would become 2. And I'm just going to bring down the last part, that minus 2 times the square root of 5. Now we can simplify this part. So negative 4 times the square root of 5 minus 2 times the square root of 5. Now we have the same index and the same radicand. So I'm going to write this like this. Negative 4 minus 2 times the square root of 5. So I'm just focusing on the numbers in front. Simplifying that part. And then, bringing the radical next to it. Any other questions or any questions on that? In your calculator, put this in, and then put this in, and see if the decimals match. Make sure you're putting negative and then minus. This one, the original, and then this one, and see if they match. So they match, and that means we're good. So these are nice because you can still check them in the calculator until we get to variables. We'll cross that bridge later. So let's do some more. Let's do number 2. These are both square roots. They both have the same radicand. So we don't have to simplify anything. We just need to take the numbers outside. And add them together. So our simplified answer will be what? 4 and 5. Let's do number 3. Can we add these together as they are? No. We need to simplify it. The square root of 63. What is the highest perfect square we can divide by 63? 9. 9 and what? 9 and 7. The square root of 9 is what? And I'm going to bring down the first one. So we can multiply 2 and 3 to get 6. Now can we add them together?
Yes.
Yes. So what would our final answer be? 16 times the square root of 7. Number 6. Here we would need to simplify both of them. What is the highest perfect square we can divide out of 28? And the square root of 4 is 2. We have 2 and 4 and 7. And then the highest number, or the highest perfect square we can divide out of 112. You may have to do some work on that one. 16 and 1 is 1.37. We have times 4 times the square root of 7. And then we can multiply both of them. So negative 8 times the square root of 7 plus 16 times the square root of 7. So our final answer would be what? 8 square root of 7. Let's check this because we have to simplify both. Put this original in your calculator and then put the answer in your calculator. See if those match. Do we want to do 1 of 7 or 8 or move on to the next page? Seven. Again, we have to simplify both. What is the highest perfect square we can divide out of 160? And 10. The square root of 16 is 4. And then the highest perfect square we can divide out of 90. Um, 9 and 10, yeah. Square root of 9 is 3. So then we can multiply. Negative 16 times the square root of 10, minus 6 times the square root of 10, would give us say that one more time. This one? You said bring it down. I don't think I'm understanding this. Bring it down with what? We have to multiply these two. What would our final answer be? Flip over to the next page. Now these are a little bit more challenging because we have 3 and we may be adding some, subtracting some, it just depends. So we'll do a few of these. Starting with number 9. Can we add these all together? No. We have 2 that have the same number, but 1 that does not. Are these as simplified as possible? No's, and I saw some yeses. Give me two factors of 10. 2 and 5. Those are both prime. I cannot make a pair with those, so 10 is as simplified as possible. What about 6? Factors of 6. 3 and 2. Those are also prime numbers. I cannot simplify that.
I thought you meant like simplifying as factors.
Got it. So yes, we can do that. We cannot simplify the radical form. Right, so these are as simplified individually as possible, so let's combine them. Our like terms here will be these two. Negative 4 times the square root of 10. And then we have minus 3 times the square root of 6. Hold on one second. The order here does not matter. If you put negative 3 times the square root of 6 minus 4 times the square root of 10, that would be the same thing. As long as you're keeping whatever the sign is the same, if you change that sign, then yes, it would change the answer.
Why is that negative 4 if it's negative 2 square root and 9?
So these are being multiplied together. They're subtracting from each other. No. We're going to get some multiplying ones too. But you'll be able to tell the difference. Like, negative 2 is being multiplied to the square root of 10, but this is not being multiplied to this. Here, you'll be able to see that they're multiplying. Let's jump down to 13. We can put this all in, and then put this in. It should match. I'll do that. Negative 2 times 10. Minus 3 times 6. Minus 2 times 10. Negative 4 times 10. Minus 3 times 6. Or something like 13. Can we add these together, subtract these together now? We need to see what can be simplified and what cannot. Is 8 prime?
Yes.
So we can definitely simplify it. Highest perfect square that we can divide 8 by?
4.
4. And 2. Square root of 4 is 2. And we're going to bring down this negative 5. You can multiply as you're going through. I'm just going to do that all at the end. Highest perfect square we can divide out of 45. 9. Which would give us 3 times the square of 5 plus the 2. And then for the last one, highest perfect square we can divide out of 200. I also can't hear very well, so if you decide to get hard to 25 works is the highest. 102. So that would be 10 times the square root of 2 times that 3 outside. It's really easy for things to get lost with these. Be very careful. Bring everything down. So you have negative 10 times the square root of 2 plus 6 times the square root of 5 plus 30 times the square root of 2. Can we simplify this anymore? Do we have any similar radicands? So that would be our final answer. Put that in your calculator really fast because there's a lot of things we simplified and a lot of things disappear. So put that original in your calculator and then that final answer and see if you get the same thing. You get the same thing? Yes. Right, we're going to do one more of these type of problems and then do one of these problems. It looks complex because it's a bunch of words, but it's not that. So for 16, this now has 4 terms. Can we simplify any of these? 8. That would be what 2 square roots? 4 and 2. Right, so this term alone becomes positive 8 times the square root of 2. And I'm just going to bring down everything else. Can we simplify anything else? Yes. What? So we may not be able to simplify radicals anymore, but can we combine the 6's? So that would become negative 8 times the square root of 6. No, we cannot multiply. The 2's. And that would become once you get the hang of it, it's not that bad. It's just a lot of simplifying radicals and then simplifying radicands together. We're going to do 18, and then I'm going to let you practice some of these. For 18, we're talking about the length and width of a rectangle. And we know 2 of those. So you can do one of 2 things with this. Either draw yourself a rectangle, put those 2 on it. So let's say this is the width, this is the length. We're looking for, the perimeter. How do we find perimeter? Add up all the sides. But with this, they only give you 2 of the sides. So we would also need to add this up here and here. But we need to do a couple things. We need to simplify these first. You could have also used your perimeter formula for a rectangle. You would just need to be careful here. Don't forget your 2's at the very end after you simplify them. No matter which way you do it, you have to simplify first. So let's do that. What is the highest perfect square we can divide out of 405? 81 and 81 and 5. That would give us 9 times the square root of 5 times the 2 that was out here already. So just this part would simplify to 18 times the square root of 5. And then what is the highest perfect square we can divide out of 48? 16 and what?
And 3.
Square root of 16 would be 4. And we would bring down this 9. So just this part simplified would be 36 times the square root of 3. So then you have a choice. Do you want to take this plus this and this plus this, add all of those together? Or do you want to do 2 times this plus 2 times this and get that? Doesn't matter, you're going to get the same answer either way, it's just how you start to do it. I'm going to use this one instead of writing this out. Multiplying this out, this would give me 36 times the square root of 5 plus 72 times the square root of 3. If I actually wanted to know what the perimeter was in numbers, I could put all of that in. I don't really care to know that number. I just needed to simplify it. You can if you so choose. What questions do we have on this or adding and subtracting radicals in general? I don't want you to do all of the ones we did not do, so I'm going to pick certain ones for you. So let's say 1. Eight. 11, 14, 15, and 17. 3, 4, 5, 6. 1, 8, 11, 14, 15, and 17. Work on those for the next 10-ish minutes, 5 to 10 minutes, and then we'll come back and we'll check those and then start the second part of this. So we can start on the next part. We probably won't finish that, but it's okay. Number 1 was just the square root of 6. So if you put 1 times the square root of 6, that's fine, but you won't usually see that 1 in front. Number 8 was 33 times the square root of 5. What questions did we have on that one? Number 11. Final answer, negative 2 times the square root of 2 minus 3 times the square root of 3. If you switch that, that's okay. Number 14 was 88 times the square root of 6. You were able to simplify or combine them all because they have the same radicand. What questions do we have on those two? Number 15 was negative 4 times the square root of 5 plus 3 times the square root of 7. And 17's final answer was 52 times the square root of 2. What questions do we have on either of those? If you did not get to either of those, go back, make sure that you practice those and that you do those. If you have questions on any of those, or maybe you think of one later, make sure you get that question asked. Find this page. With this, some of the things we were talking about with adding and subtracting applies here, but not all of it. So we're going to multiply the coefficients, the numbers on the outside together. But then we're also going to take what's on the inside of the radical or the radicand and multiply those together. So when we simplify, usually whatever is on the inside, we bring it all together. That's this product rule. Anytime we are multiplying something by the square root of something else, we can combine them and put everything underneath the same square root. Sometimes we will need to simplify whatever we multiply together. Sometimes we won't. It just depends. So let's do some of these. For number 1, you have an invisible 1 on the outside here. So you're going to multiply 1 times negative 3. And then on the inside, you're going to be multiplying 8 and 2. So, say that one more time. Multiply the outsides together and the insides together, yes. So what would the outside be? Negative 3. What would the inside be? The square root of 16. We can simplify the square root of 16 without the perfect square to just 4. So our final answer here would just be negative 12. Sometimes that happens and the radical completely goes away, sometimes it doesn't. What questions do we have on that first one? Let's jump to number 3. Same thing, but now we're multiplying 5 and negative 7 on the outside and 10 and 12 on the inside. On the outside, we have what? 5. On the inside, we have what? We can simplify 120. It's not a perfect square, but what is the highest perfect square we can divide it by? Check it. I don't think 36 is. 4 and 30. So 4 is actually the highest perfect square. And now let's think of this. Can we simplify 30 more? Yes. To 5 and 6. And then simplify 6 to be 3 and 2. But 5, 3, and 2 are not pairs. So that's as far as this is going to go. Negative 35 times 2 is negative 70. So this looks like we should simplify it more, but 30 wouldn't simplify more. Okay. Right, so like I could write this down. 5 and 6, and 3 and 2. But none of these are pairs of the same number. So nothing is going to come out. So yes, I can break it down more, but it would just be 5 times 3 times 2, which is just 30. So that's one of those weird ones that, yes, it's 30 is not prime, we could keep breaking it down, but when we do that, nothing would change. We wouldn't be able to bring anything out. Let's jump to number 6. 6 now has variables. So be careful with this. On the outside, we have negative 5 times 3. On the inside, we have 20x times 15x. On the outside, we have what? 20 times 15 is what? 100. And if we're multiplying these x's together, we're like adding their exponents together. So this would be x squared. So now we have to simplify 300x squared. What is the highest perfect square we can divide 300 by? 100. 100. And 3. Square root of 100 is 10. 7. Say that one more time. Would be negative 15 times 10 times x times the square root. We just haven't broken down the x part. 2 goes into 2 how many times? 1. That would be 1x that comes out. So if I rearrange all of this, we have negative 15 times 10 times x times the square root of 3. And our simplified answer would be what? So since we have variables again, what kind of sucks is that we can't check the variable part in the calculator, but you can check the numbers. You could put this in as negative 5 times the square root of 20 times 3 times the square root of 15, and you should get the same decimal answer as negative 150 times the square root of 3. Really quickly, we'll do 7 and then we'll do 10 and then we'll be done for today. For 7, outside, so that's just going to be 2. On the inside, we're multiplying 15 w to the third and 3 w to the fourth. 15 times 3 would give you 25. How many w's do you think you have? 7. Now we need to break this down. What is the highest perfect square we can divide by 45? find. We have 3 times the 2 from the outside, times the square root of 5. 2 goes into 7 how many times? 3. So that would be W to the third. With how many left over? 1. So on the outside we have 2 times 3 times W to the third. On the inside we have 5 and W. What is our final answer? 6W to the third times the square root of 5W. Again, you could check the decimals, but not really the variables. Multiplying is nice because you were literally just multiplying everything together. The only downside of that is you have to simplify at the end. Sometimes you'll get examples like 10 though, where you're not just multiplying. So be very careful with things like these, because if you're not just multiplying, you have to think about your order of operations. Would you add these first or multiply these first? Multiply. We're going to do that first. There's nothing on the outside of these. I'm going to just bring this one down. And then if I'm multiplying these together, 12 times 2 would give us 24. X squared times x to the fourth would give us how many x's? 6. So now we're going to simplify this. What is the highest perfect square we can divide out of 24? 4. So that would give us 2 square root of 6. 2 goes into 6 how many times? 3. With nothing left over. I'm going to bring this down. So we have 2x to the third times the square root of 6 plus the original 7x to the third times the square root of 6. The last thing with this, these both share the same radicand, yes. We also have to remember our rules for combining like terms with this variables. They have to have the same variable and the same exponent. These do, so we can combine. If this was x squared and this was x to the third, we would not be able to simplify this. So what would our final answer be?
9x to the third square root of 6.
Correct. So next class there is one last thing we have to talk about. So I'm going to give you time to practice this. We're going to talk about this, and then we're going to do some problems from the review.